Alright, so today we'll be talking about the substring with concatenation of all words problem. You are given a substring S and an array of strings words of the same length. Return all starting indices of substrings in S that is a concatenation of each word in words at least once, in any order and without any intervening characters. You can return the answer in any order. So going through the examples, we want to find the words foo and bar each at least once within the substring. Bar foo and foo bar right here, 0 and 9, makes sense. Here we want to find two words, one good, one best. And so since the two words are on each extreme of the word with three goods in between, won't work. And obviously this is from like a top-down perspective, it's a lot easier to see that. And then we want the foo bar or whatever. Foo bar the right here, bar the foo and the foo bar, right? 6, 9, 12 makes sense. So like always, we're going to code the edge cases if length of S is equal to 0 or S is none or words is none. None, we're going to return just an empty array because there's nothing we can do with those. Like if the string is empty or there's no string here, nothing we can do. And if this is none, there's nothing we can do there as well. So now we're going to initialize, oh my god, initialize variables. First we do count. I will explain all of the variables at the end because like I said before, I always somehow need to alter my my variables at the very end. So I will explain it all at the very end. It's a word length. Yeah, so here we will go, oh whoops, wrong way. We go horizontally. Here is the dictionary. Like many other questions that we've done before, that keeps the, instead of a character this time, it's a word and count. So basically we just want to keep, you know, however many unique words and how many times we see those words. Here it's the length of one word in the words list, because we're guaranteed that all of these words are the same length. Therefore, we can keep the length, and it can help us iterate through and answer the question later on. And so here we have the result. This is just the result list. Kind of self-explanatory. It's what we're going to return with all our answers in it. And words length is just, you can kind of just tell, it's the length of the array, length of the list times the length of the word. One word in the list. Yeah. This will, the reason why we have this will be a bit more clear, like in just a little bit. But now first we need to, we want to fill up our count dictionary. So we want for word in words, we want count word is equal to count dot get word 0 plus 1. This is just basically get our default. We get the value of the word from count, or we just default to 0 plus 1 because we want the word and the count, just like we mentioned here. And so now we need to go find substrings that answer the question. Great. So we're going to be using a sliding window. For left in range of length of S minus words length plus 1. And we want to create another dictionary here. Let me drop this down so I can write comment a dictionary that keeps track of the words we find in our window. So we're going to call this word scene, and I'm going to initialize the dictionary. And now we're going to make a right bound that we're going to let's see, how should I describe it? Yeah, essentially iterate through the right bound of the window to find words. Right, so we're going to do for right in range of length of words, because we know since every word is exactly the same length, we can just go through the length of the words list, and then once we hit the length of the words, if we actually have a substring that satisfies the answer, the problem statement, then we can just append that to the list. If not, we can just move right along. Oh, okay, actually, yeah, I didn't explain this part. So the range of length s minus words length plus 1. So we'll use the first example. So since this is 6 characters long, because 2 words of 3 characters long each, we know that if there's only 5 characters left in the word, it's impossible for us to find an answer, right? So basically, if we do this, for range and length of s, we'll basically go from index 0 all the way until we hit this last index for the character, right? And just using logic, we know we only need to go as far in the string until we have 6 characters left. We don't need to go from 5 or 4 or 3 or 2 or even 1 character, right? Because it's automatically not going to work, guaranteed. And then just to prove that this logic works, here's 16 characters, right? Because four letters, 4 words, so 16. So if we're at 15 characters left, it won't work, because there's no way we find 16 characters within 15 characters, right? And I guess just one last time, since we're already doing it anyways, this is 9 characters, because 3 words, 3 characters each. So 9. So if we go 8 characters, if we're 8 characters from the end, it's impossible to find, right? So that's why we have the minus words length. And then the reason why we need this plus 1 here is because when we do this, right? So for this, I'm going to do some quick math at the bottom here. This is 1, 2, 3, 4, 5, 6. This is 18 characters long, right? The length, let's see. The length of this is equal to 18, right? We're going to use the assignment, but it doesn't matter. And the word's length of this array is 6, right? So then when we do 18 minus 6 is obviously equal to 12. And since range will only go 0 through 11, the range of 12 will end up giving you 0 through 11, right? But we still need the 12th index. 0, 1, 2, 0, 3, 6, 9, 12. We still need the 12th index because that's still 6 characters, right? We need the 12th index still. And this stays true for every single one of these, right? But I'm just not going to do the math for those. And so you can just do plus 1. And so that's why we do this word's length. This just optimizes the solution for the longer the words list is, or like it doesn't have to be the longer the words list, but like the longer the word's length is, so the length of the list times the length of each word, the longer that is, this optimizes the solution more, right? So now we're going to iterate through the right bound of the window to find words, and so we're going to make another. Whoa, why is this red? Okay, not sure why that was red. We're going to make another variable called word index. Okay, yeah, let me just label it. This tells us where our word will start, right? And so word index is equal to left plus right times word length. So basically, we'll just do it for the very first loop. So when left is equal to 0 because we're starting at the very beginning, right is also going to start at 0 because it's from 0 to the length of words, which is 0 and 1, because it's a range of 2. So we're going to start 0 plus 0 times 3. So we're just going to start index 0. And then here, we're going to do this. We're going to call a temp word, which is s word index, and then word index plus word length. So basically okay, I'll do it for the second iteration just so it makes more sense. So left is still equal to 0, and right is now equal to 1, so this will equal to 3. So we're going to be at an index of 3:6. I can't math. Like this, right? And then so since this part is inclusive, this part is exclusive, we have index 3, 4, 5. So that's the word that we're going to have on a second iteration of this for loop, right? So temp word just holds the word, like that makes sense. If temp word not in count, we can just break, because if the word that we found is not in our count array, or count dictionary, which just counts every word and stores the count here, if it's not there, so for example, if we're here, we go arf is obviously not in here, so we don't even need to continue looping through the rest of this. We can automatically break because we know that word's not going to be in there, and so we can just ignore it, right? But now this is the case where the word is there, so we need to do dot get temp word 0 plus 1. This works exactly the same way as we did it up here. Whatever word we want to add it in here, if it's not in there yet, then we'll just get a 0. If it is, we'll get whatever value it is and plus 1. And then we need to do another check just to make sure that we're still staying within the bounds of the substring, which is we can't have any extra characters, right? Sorry. If words seen, if the count that we have in words seen is greater than the count that we have in our actual count. So let's just say we see the word good twice in our loop, but we're only supposed to see it once, then we know we can just break here because we're not staying within the bounds of our for loop. Or like, no, staying within the bounds of the problem statement. And so we can exit out of the for loop, yes. And then so now if we need to do this condition just to see append left. So this is just to make sure, because we broke out of this for loop, whatever current iteration we're on. And so after exiting, we don't know whether or not we broke out of this. So we can just check to see if these are exactly the same, or even if we didn't break, right? It's possible that it's not the same. So we can just, we have to make sure using this if statement, And this does deep equality, so it checks the word, like for every tuple in the dictionary, the key value pairs, just to make sure they're all the same. And if it's the same, then we're going to append it, right? And at the very end, we're just going to return res, which is to return the result. And yeah, let's see it. Okay, so I was going to try a different solution, but I don't think it was gonna work. It was going to be part of the end of the video where I try it, but I couldn't figure it out. So I'm just gonna end up cutting it and then just appending this to the end of the video. So yeah, thanks for watching. This is going to be the last question for the sliding window, at least for a little bit. Tomorrow we'll be starting on the 2-pointer questions. And yeah, I will make a video on introducing how you can recognize that you're going to be using a sliding window technique. So yeah, that'll probably just be like an extra video in a sense where I'll still do 1 Leetcode a day, but that video just comes out when I have time to explain my thought process behind identifying sliding windows. But yeah, aside from that, thanks for watching.